Okay, how to complete a frequency distribution table. Let's do this together. You'll see here I've copied table 3.2 from your textbook. And this shows the 10 values, that is the 10 ages, that were observed in the emergency room. Of course, each age represents a different subject, and we saw 10 adolescents coming into the emergency room during the observation period. And each of these table cells shows you the age that was observed. One kid had an age of 14, one adolescent had an age of 16, the next one 15, 16, 15, 15, 18, 16, 16, and 16. Now, to be able to put those values into a frequency distribution table, the first thing you need to identify is what is the lowest value and what's the highest value. If we go through here, we can easily see the lowest value is 14 and the highest value is 18, right? And how many unique values does that span of scores represent? 14, 15, 16, 17, 18. The range, the span of values from 14 to 18 represents 5 unique values. So in your frequency distribution table, you're going to have 5 rows, 1 row for each unique value that was observed. Now, to complete the frequency distribution table, you start at the lower left-hand corner and you enter the lowest value that was observed. In this case, it was 14. And you go up 15, 16, 17, and 18. Now notice something important here. We've added a row for the age of 17. Did we observe an age of 17 up here? No. But in order for your frequency distribution table to be correct, you must enter the value of 17 because it fell within the span of scores, within the span of from lowest to highest that were observed. All right. Now the first column that you calculate is the frequency, and this is really easy. How many times did age 14 appear? We see it was once, right? How many times did age 15 appear? 1, 2, 3, right? You put a 3 here. How many times did age 16 appear? 1, 2, 3, 4, 5. And we've already determined that age 17 was never observed, even though it's in the span of scores, and age 18 was observed 1 time. Okay, now we do the cumulative frequency column. Now, cumulative frequency is showing you at any age point in your span of numbers how many total cases have occurred, and you're going to understand when we get to percentile rank why that's an important number to figure. We always start at the bottom on the frequency distribution table, so the cumulative frequency at our lowest value is of course equal to the frequency of the lowest value, the frequency at which the lowest value occurred. So that's a 1. Now, to get the cumulative frequency at age 15, we add 1 to 3 and we get 4. For 16, we add 4 to 5 and we get 9. And 17 is a 0, so that will again be 9. And then for 18, we've accounted for all of our cases. 10, right? And we had 10 cases. Now, relative frequency is the frequency at each score observed, or each age in this case, divided by the total number of cases. Total number of cases in this case were 10, right? So 1 divided by 10 is 0.1, 0.10, or you could say 10%. 3 divided by 10 is 0.30. 5 divided by 10 is 0.50. 0, of course, this is 0. And 1 divided by 10 is again 0.10. Now, percentile rank is calculated a little bit differently. Percentile rank is the cumulative frequency divided by the total number of cases observed. So in this case, of course, cumulative percentile rank here is 0.10. Percentile rank here is 4 divided by 10, which is 40. 9 divided by 10 is 0.90. and it's the same for age 17, even though that didn't occur. And then by the age of 18, we see that all cases were accounted for, or 100%. Now, when I talk about percent, of course, I'm transforming the decimal into a percent. 0.10 is 10%, 0.40 is 40%, 0.90. And what is this telling you? It's telling you that by the age, when we're talking about the range of ages observed, 90% of the cases were accounted for by ages 16 or lower. All right? All right, that's a completed frequency distribution table.